Hello, so now we're going to talk about yield curve fitting, that is estimating the term structure of interest rates. Okay, recall that the term structure of interest rates is defined as the zero coupon rates. Okay, so until 1 year we have treasury bills that are zero coupon bonds, and therefore we can immediately get the zero coupon rates that come from those bonds. But after 1 year we only have coupon bonds. Okay, so we will have to come up with some technique to estimate not the yield to maturities on the bonds, on the coupon bonds, but actually the zero coupon bonds that were applied by traders to each one of the coupons to arrive at the price of that bond. Okay, so the point is that the only thing that is observable in the market are bond prices. We all agree on those numbers, but from those bond prices we have to estimate the implied zero coupon rates that were used by traders. Okay, we're going to look at three different methods, from the more simple method to more advanced methods. Okay, so let's start with the first one, the bootstrap. So as the name suggests, this is like the strap going through the holes in your boots. We start from one hole, then we move to the next, then to the next, then to the next, and we do this zigzag procedure, right? So here what we mean by that. We're going to start with the shortest treasury bill that we have, and we're going to get the yield on that. Then we move to the second bond and get the yield on that. Then to the next maturity and get the yield on that third bond, and so on. So from the shortest to the next one, until we get to the longest maturity bonds. All right. So let's see this with an example here. I have here 3 zero coupon bonds, so 3 treasury bills with 3, 6, and 12 months maturities, and then I have coupon bearing bonds, 3 of them, A, B, and C, with maturities of 1.5, 2, and 4 years, and the corresponding coupons. Okay, so the idea is the following. I'm going to start with the first zero coupon bond, and immediately from the price I get the discount factor for 3 months. Then from the next one I get the discount factor for 6 months, and then the discount factor for 12 months. Okay, that's immediate. The difficulty now comes when we go to the coupon bond. So the first one is this one that has a maturity of 1.5 years, meaning that we have 2 payments ahead of us, one at 1.5 and the other one at 0.5, right? So the idea is that the price of the bond, the market price here, has to equal the present value of future cash flows. The first cash flow is 0.7. That's going to happen 6 months from now, and I'm going to use the discount factor that is already determined here for 6 months. And then I have another cash flow of face value plus coupon at 1.5 years. So this is the unknown that I have, the discount factor for 1.5 years. Okay, so solving this equation gives me this discount factor for 1.5 years. Okay, and then I keep doing this for the remaining bonds that I have in the sample. There are some details here about interpolation and so on. Please go through this. I imagine that most of you have done this in investment courses before, but if there are any questions, we can go through this in class. Okay. So this is the final result, the discount factors, and then from the discount factors I can always compute any interest rate that I want. In this specific case, these are interest rates with continuous compounding, okay, which are the rates that we will use throughout this section. Okay, so just before we move on, let me show you here an Excel file just to warm up. So what I have here are the bonds, the 6 bonds that I just described. These are the corresponding maturities, and I have set up the cash flows like this. So this is the cash flow of the first treasury bill, the cash flow of the second treasury bill, and so on. These are the market prices of each bond, okay? And then I can, for the bootstrap, I can either do the calculations like I just described by hand, or I can use Excel here with a solver to actually find the discount factors. I was calling it Z on the handouts. Here I'm calling it T, but these are discount factors for each maturity that, once multiplied by the for example here, once multiplied by the coupon, gives me the present value of that coupon. And then when I add up all these cash flows, the bond value that I'm getting should equal the market price that is up here. So the difference should be small, and I can use the goal seek or the solver in Excel to actually compute this automatically without having to solve all those equations by hand. Okay.